All right, so I want to just pick up where I left off today on, I think it's page 44 with these example problems. And when you're doing these problems, you might want to refer also to the flowchart, the summary of the counting methods that we went through briefly today. So, example 1, from a committee of 8 people, how many ways can we choose a subcommittee of 2 people? So the first question, with or without replacement. So we want to choose 2 different people. So obviously we are going to choose without replacement. Does the order matter? We're just choosing a subcommittee, a group of 2 people. So no, the order does not matter, which means if you look over here that we are going to use combinations. Okay. There's a total of 8 people, that's N. We want to choose 2 of them at a time, that's R. So in other words, I just want to do the combinations of 8 objects taken 2 at a time. Okay, you can just do that on your calculator and you should find that that is 28 ways. Okay. All right, so example 2, from a committee of 8 people, how many ways can we choose a chairperson and a vice chair? Again, we are choosing without replacement. Does the order matter? In this case, it does, because we're specifically choosing a chair and a vice chair. So it's different, for example, if I choose Erica to be the chairperson and Samantha to be the vice chair, versus if Samantha is the chair and Erica is the vice chair. So the order matters. So if we come back to the flow chart, this time we want to come down this way. The order does matter. All the items are distinct. So I want to use permutations. And again, the total number of objects is 8. And we are choosing 2 of them. So R is 2. So this time I want to do the permutations of 8 objects taken 2 at a time. Go ahead and do that on your calculator and you should get 56. All right, so example 3, how many 5-card hands can be dealt from a full deck of 52 cards? You want 5 different cards, so of course it's going to be without replacement. Does the order matter? No, it does not, because they're just dealing out the cards. It doesn't matter what order they are dealt in. You're just going to pick them up and rearrange them however you want anyway. So we have a total of 52 objects. We are selecting 5 of them at a time. Because the order does not matter, we're going to do a combination. So in other words, a combination of 52 objects taken 5 at a time. And if you do that on your calculator, you should find it's 2,598,960. Okay. All right, so what I would recommend that you do right now is pause this, go on to the next 2 pages and attempt to do the problems by yourself, and then come back and I will go through the solutions for each one. All right, so right now I'm going to erase all this. Go ahead on to the next 2 pages. All right, so number 1. How many ways can a 10-question multiple choice test be answered if there are 5 possible answers for each one? I gave you a hint. It's kind of like the license plate problem in that there are 10 sequential things. So in other words, first question, second question, third question, and so on, all the way to the 10th question. Each one, there are 5 possible ways to choose the answer. So we're just using the multiplication rule here. So there's 5 ways to choose the first one, there's 5 ways to choose the second one, and so on, 5 for each one. And remember, there were 10 total. So in other words, it's ultimately going to be 5 raised to the 10th power. And if you multiply that out, it's 9,765,625. All right, number 2, 10 people gather for a meeting. If each person shakes hands with each other person exactly once, what is the total number of handshakes? All right, so the items being selected are the people. So they're being selected without replacement because you need 2 different people to make a handshake. So how many total items are there? There are 10, so that is N. How many of them are being selected at a time? 2, because you need 2 people to make a handshake, right? So in other words, R equals 2. Does the order matter? No, it does not. Because if I shake Syra's hand, that is the same as Syra shaking my hand. The order does not matter, so therefore we're going to use combinations. So we need to calculate the combination of 10 items taken 2 at a time. All right, if you calculate that, you should find that it is 45. Okay, number 3, Washington State Lotto. They pick 6 different numbers, so in other words, it's without replacement, between 1 and 49. What is the probability of winning? So first we have to, calculate how many ways are there to pick the 6 different numbers. Okay, so they're different, so without replacement. The order does not matter. You're just trying to pick a group of 6 numbers. Okay, there are a total of 49 objects. You are choosing 6 of them. The order does not matter, so therefore you want to do a combination of 49 items taken 6 at a time. And if you calculate that, you should find out it is 13,983,816. Okay. And then the actual question is, what is the probability of winning the lotto? There's only one way to get the correct 6 numbers. So only one way to make you happy, divided by the total number of outcomes. All right, and if you do that, again, it's a very, very small number. In decimal form, 0 point, and I'm not going to write out all the zeros, but there are 7 zeros, and then 715. Okay, 7 zeros, 715. Or in scientific notation, 7.15 times 10 to the negative 8. All right, number 4. A nurse has 6 patients to visit. How many different ways can he make his rounds if he visits each patient once? So the items being selected are the 6 patients. They're being selected without replacement. The order matters. That's the whole point of the question. How many different orders can he go to visit the patients in? So the total number is 6. All of them are being selected because he's going to go visit all 6 of them. The order matters, so in other words, it's a permutation of 6 objects taken 6 at a time. And this is actually a case of the special permutation rule. How many ways can I arrange all 6 patients? So this is equivalent to just doing 6 factorial on your calculator. So either way, you should see that there is 720 different ways to visit the patients. All right, I'm going to erase all this so I can move on to the next page. All right, number 5, a German Shepherd has to go get the correct 2 objects from a set of 20 objects. In how many ways can he pick the correct 2 objects? So the items are being selected without replacement because he's going to get 2 different things. There are a total of 20. How many are being selected? 2 of them, so that's R. Does the order matter? It does not say anything about he has to bring them back in the right order, like first the frisbee, then the ball. It doesn't say that, so we're going to assume that it does not matter. So therefore, we're just going to do a combination. So a combination of 20 objects, sorry, that's a 20, taken 2 at a time, and you should do that on your calculator, that it is 190. Okay, number 6, slot machine, 3 different wheels, 12 different objects on a wheel. How many different outcomes are possible? In this case, think of this as being 3 sequential categories, okay? So up here. So first wheel, second wheel, third wheel. Each wheel has 12 possible outcomes. So using the multiplication rule, we're just going to multiply those all together, and you should get 1728. All right, number 7, jumble puzzle. You have to unscramble the letters. How many different ways can these letters be arranged? So first of all, count up the total number of letters, and you should see that there is a total of 10 letters. However, they are not all distinct. Some of them are the same. So for example, there are 3 S's, there are 3 T's, and there are 2 I's. The rest of the letters, there's just 1. So we're just not going to be concerned with those. All right. So in this case, the order matters. That's the whole point. How many ways can we order the letters? Are all the items distinct? No. So we're going to use that special permutations rule. All right. So the number of permutations, it's going to be n factorial, which is 10 factorial, over, and then I've got a 3, a 3, and a 2. So I got to do 3 factorial, 3 factorial, 2 factorial in the denominator. And like I said in class, remember when you do that on your calculator, you got to put parens around that. So if you calculate that correctly, you should find that it is 50,400. And I'm confident that you can all unscramble that into the correct word. All right, last one. City Council, there's 5 men, there's 4 women. How many different subcommittees, okay, can be formed that consist of 3 men and 2 women? All right, so this is, if you come over here, the special case if you are selecting or drawing from 2 or more subgroups. So this is exactly like the cracked eggs problem. All right, so out of the 5 men, I want to choose 3. So combination of 5 objects taken 3 at a time. And then out of the 4 women, I want to choose 2. So multiply that by the combinations of 4 objects taken 2 at a time. So you should find that those are respectively 10 times 6, and the total ways to choose then is 60.